Well, good afternoon, everybody. Again, it's Rob here. Hope you're all well. It's Wednesday, the 12th of March, just around half past midday. I want to talk about a subject that's slightly going off heating design for a second. It's something that's been bugging me for many, many years, and what people tend to get wrong most of the time. And I think a lot of it is just due to not really understanding how to set these things up. But I want to talk about combi boilers, combination boilers, and I want to talk about the hot water side of combination boilers in particular. I have been talking about this, say, for a few years, and a few of you that's been on my face-to-face training courses, we have discussed this. But there's some new information I think that is coming out, and I want to try and sort of really sort of like delve down into it a little bit deeper, just to kind of do some maths and kind of get this right, because there's so many parameters with setting up the hot water side of a combination boiler that is any really instantaneous heater, really, to be fair. They just get missed, and I'm not really sure as to why this happens, but I guess it just does. But anyway, what we'll do, we'll crack on. There's a couple of things that when we're sorting out hot water, we've got, because we now know that delta T, and we now know how to calculate mass flow rates and all of those sorts of things. We also know that we design everything now to 1 meter per second, because that is literally the Goldilocks zone. So we'll play around with the High Tools app again with this tutorial and see. But it's say setting up hot water for me is one of the biggest kind of wastes. I've been into so many properties and seen a hot water tap come on and the boiler starts cycling like crazy because it can't dump the heat quick enough, so there's too much energy going in, not enough flow rate, maybe the temperatures have varied and all that sort of thing. So we'll get into that conversation right now on the very next slide. So water temperatures and flow rates of water. Water temperature, first of all, of cold water. If you're connecting your combination boiler up to an option of putting it onto the cold water mains, and let's be very, very clear on this, a combination boiler for the hot water side only doesn't just have to be connected to water mains. It can be connected to a low pressure system, a tank fed system, or anything like that, so long as you can match the flow rates. And we'll come on to that sort of shortly. And there's some virtues of doing it by stored water, and there's some virtues of doing it through mains, but we will come to that as we move forward with this. Very important that we're working further with these British standards, which is EN 806 and BS 8558. ACOP L8, which is the protection of Legionella, doesn't apply to combination boilers. It only applies to stored water and obviously dead legs and that sort of thing. But again, we'll come on to that shortly. But what is very important to do is to make sure that any cold water supply is not stored or does not have the ability to exceed 20 degrees in any 24-hour period. And that is for microbial growth within pipework, and that can be anything from Legionella to Pseudomonas and all sorts of other things. I mean, that's another huge subject which we could talk about on a different tutorial video in the future. I mean, to say this is wide open run of videos, and again, a lot of these are mainly my opinion of what I've learned over the whole of my sort of 43 years so far within the industry. So insulation is really important, but one thing that is incredibly important, which we seem to get wrong all the time, is on the next slide. So when you're installing pipework, we should know that a water main, and everybody that has done their RAS water regulations, etc., they should understand that we have to bury pipework to a certain depth. Now, I'm pretty sure that any engineer that's watching this tutorial knows that you can sit outside somebody's house and find their main stopcock, and you can see that it's never ever buried down to the regulatory depth of between 750 millimeters and 1350 millimeters. When we were doing water mains, or when I was doing water mains, when I started my apprenticeship back in 1982, we were digging every water main out by hand, and we were digging them out to a metre deep. We always buried everything at a metre deep. Now, why do we do that? Well, there's a few reasons, obviously, which make sense. The shallower that pipe work is, the more susceptible it is to temperature change or temperature difference, or delta T, if you like. That is the issue. And so when we get down to between 750 and 1350 deep, what we do is we find an ambient layer where it's out of any kind of permafrost or that sort of level. So it should be between sort of 10 and 11 degrees centigrade all year round. That is the UK regulation. It might be different in other countries, but this is where we're at. As I say, I think really 1 metre deep is absolutely perfect. Really, that's the Goldilocks zone as far as I'm concerned, to lay the water mains in. And of course, when you start looking at things like ground source heat pumps and ground loops and collector loops and that sort of thing, they generally bury them down at around 1200 to 1300 millimetres down. And it's exactly for the same reasons. You get an ambient temperature of the ground. If you bury collector pipework too shallow, you're likely to get ground heave in the winter, where the ground starts to freeze up and starts to swell. This is the sort of problems that you can find. So it's really important to ensure that you get that. Now, how do we know that a water main has not been installed correctly, or we've got some issues in terms of depth or changes of temperature? Well, changes of temperature throughout the year, or out the season, or even throughout the day will actually cause oxidization of the pipework. So when you look in a typical airing cupboard, you can easily tell the water main that's in there because it's the one that's the blackest, where it's had the most oxidization across it, because it's had condensation sitting on the outside of it, and that's oxidized. This is a problem that we see all the time. And condensation can cause all sorts of issues, and then it can start to bring in mold spores and all sorts of things like that, which could then cause breathing difficulties and everything. So it's really important to stick to this 1 metre deep so you can maintain that 10 degrees of incoming water temperature, 10 or 11 degrees of incoming water temperature. And of course, that is well underneath your any microbial growth scenarios of 20 degrees centigrade. But buried shallow, and I say I've seen water mains by even water suppliers that is literally just under the pavement, so less than 100 millimetres or 150 millimetres deep underneath the final ground finished surface, which is clearly not acceptable, and that's causing downstream issues. So that's one point. So when we do the calculations on this, and we're doing temperature rises, we know that we've got a temperature rise within hot water, a combination boiler, of a DT of 35. That is our general rise of temperature to get it to our hot water coming out of our tap. And we know that we have a couple of parameters. The water regulations state that outlets should be approximately 38 degrees centigrade. I tend to go a little bit higher than that and blend down afterwards with mixing. But that's just because I'm looking at 10 degree water coming into the system and a 35 degree delta T, which will give me a flow temperature coming out of my taps at 45 degrees. I like that on combination boilers because it's under dew point, and dew point, as we know, is 54 degrees. So even in hot water mode, your boiler will be condensing, which is exactly what we want. So we're trying to squeeze the maximum amount of efficiency out of it. So we can do a few calculations, but I'd like to kind of explain a little story why I think people get this wrong so many times. The idea of putting a combination boiler on a water main is if you don't have enough stored water within your property, or you don't have enough pressure within your property, but we can get over those problems. So if we bury water into the ground at 1 metre deep, or something along those lines, we're going to be looking at around 10 or 11 degrees of supply water temperature. If we put that and we utilised let's just say you were doing an upgrade from a system only boiler to a Combi boiler. I'm not sure why you would do that these days, but if that's what you wanted to do, you will likely have a cold water storage tank within the loft space. If that is the case, as long as that tank is a GRP rated tank and it's got good insulation on it, stored water will generally sit within that tank at around 15 degrees. Now that reduces your delta T of how much you actually need to heat that water up. So you could actually say, instead of 10 degrees, you've got 15 degrees stored water. You don't need to heat up to 35 to get 45 out. You can actually just heat up 30 degrees. So you can change your delta T, and we'll have a look at those in a second and see what difference it actually makes with this. But again, it's all about squeezing the most amount of efficiency that you can out of a hot water system and getting it right. So we've got a few parameters. We said we wanted to design to 1 metre per second with all systems, whether it's heating systems, cold systems, hot water systems or anything. We decided one metre per second. We know the reasons why. If we start to go over 1.5 metres per second, we get a few things that start to happen. And this happens especially on very, very high pressure combination boiler systems. You'll start to get system erosion. If you go over 1.5 metres per second, I mean, SIBSI do state you can go up to 3 metres per second, but I know what happens when you get to 3 metres per second. You'll get water hammer, you'll get system erosion, you'll get banging pipe work, you'll get a lot of noise within the system, but you're also more likely to get component failure. And that is the sort of thing that I want to do. We're trying to, we're engineers. We want to try and just keep the system running nice and smooth, nice and easy, and no dramas to anything. Now, you can obviously buy things like shock arresters and that sort of thing to put on combination boilers or cold main systems or whatever it is that you want to do to stop that initial bang when you turn a tap on or something along those lines. So that's that point, and I'll come on to the next slide now. So apart from temperature control that we need to work out, and of course if the water main is not buried correctly in installation terms, that temperature will fluctuate even through the day because it's too close to the surface air temperature. This is something that we then will have a detrimental effect on efficiency of the boiler of trying to set it up on the hot water side. But the other thing that we have, and the other point that we have, is pressure and flow rate. Now, we talked about putting a pressure reducing valve on a system depending on what your incoming pressure is. And one thing that we have to remember in the UK, and certainly in the southern parts of the UK, most water suppliers will only guarantee 0.7 bar, so 7 metres of water pressure at ground level and at the entrance to your building. So this can be a problem, and we have some issues in much larger blocks of residential flats and things like that. I actually wrote a piece which gave me my qualification. It was kind of my citation, if you like, to get my qualification as an engineering technician, and it was part of proof of knowledge, if you like. But I did used to look after some blocks of properties which had communal cold water storage tanks that were actually installed on the roof space. Now, unless these are fully insulated and protected, they will also be subject to huge temperature differences throughout the year, depending on summer, winter, all sorts of things like that. Now, what the problem was is that whoever had done the original designs on this block of flats, they were allowing a certain amount of literage per person per day, and they based their stored water on that basis. Now, what various engineers that were ill-informed have done, they came in and instead of using the existing cold water supplies from the roof space to install a combination boiler, they have thought, well, we have to put it onto the water mains. So they've done 2 or 3 things of errors here. They have taken that cold water storage and they've capped it off, and they've teed into the drinking water circuits, which are not designed for large flow rates in big blocks of flats, and joined the combination boiler into those on the hot water side. Now, again, this is incorrect, but it also, what we find, and what I found after doing surveys on these properties, is that they just capped off the cold water supplies and didn't take them back to the main risers, the main riser pipework going up to the cold water storage tanks. And of course, as the water regulations state, we should never ever have any dead legs more than 150 millimetres long. That is the regulation. But of course, with all of these, we ended up getting lots and lots of dead legs, which is an issue with microbial growth. And what we started to find, I was getting clients there that were complaining, and these were generally elderly people that couldn't afford to upgrade boilers or couldn't afford to, so they wanted to stick with the original systems that they had. And I seem to remember it. They were old Potterton Kingfisher boilers in there, CF50s that were in there. I remember installing loads of them back in the day. Worked perfectly fine. They poodle along. They just do their thing. Not particularly efficient, but they're atmospheric boilers. What do we expect? But we were getting complaints from clients that were saying, "My water is tasting funny. I've had stomach upsets and all sorts of things after showering and bathing and all sorts of things like that." And after we investigated, we realised that not only did we have a plethora of dead legs off of the main riser within this system, but there was about 60 or 70% of all of the houses, all of the flats that were in this, or apartments that were in this block, had capped off the low temperature tank fed water supplies, joined into the cold water drinking water supplies. One of the first complaints that came back was the people on the top floor were saying, well, we're trying to have a shower in the morning when everyone else is trying to have a shower, and we just don't get any water out of our taps. And that's purely because it was designed on a drinking water circuit and not on a full water supply circuit for bathing, etc. So what was the answer? And we found out that obviously the tanks or the stored water in the roof space, and we got the reports from the hygienic companies that come out once or twice a year to check for bacterial growth in stored water tanks on the roofs or wherever they're stored. And what it turned out to be is that the water levels were so high in these tanks, and of course it wasn't getting used because 60% of the whole block had been taken off of these and all their water came from the drinking water circuits. So there's an error on the people that are doing the surveys, the engineers that are trying to put these systems in. And that, frankly, is just not cricket, is it? We can see that is because people are getting made ill through this. So we had to literally go in there, evaluate who was on what water system, and then drop the water levels within the stored water in order that these properties would get the throughput that they needed and the replenishment from fresh water, so we didn't have the problems of microbial growth. We also, but we couldn't force other users that had combination boilers installed to come off of the drinking water circuit and actually reinstate the cold water circuits and then install a pump to give you the right flow rates. But because your flow rate varies right the way through, I always recommend installing a regulating valve. So a double regulating valve here, which you can adjust the flow rate to what you want. So that would go on the cold incoming side of the hot water, cold feed coming in. So your pressure reducing valve upstream, pressure reducing valve upstream here set at say 1 bar, expansion downstream of this of 1.2 bar, and then this would be set at whatever your mass flow rate calculation is for your combination boiler, whether it's an 18 kilowatt, a 24 kilowatt, or 30 kilowatt, whatever it is, but we'll do some maths on that shortly. If we decided that we were going to use an existing cold water storage tank in a 3-bed house that had a combination boiler put on, it's just got one bathroom with 1 shower, 1 bath, not used necessarily simultaneously, but it's there. You could install very, very simply one of these little showermate pumps, or not particular brand. I'm not sponsored by anybody here, so this is just an image that I'm used to. So one of these little units, and you could just pump. So you could have a tank feed coming straight out of a cold water storage tank into one of these ports, the inlet port, out of that port, and then straight down into your double regulating valve. That then would pump straight into that, and that would give you a guaranteed flow rate all the time, which is balanced to your calculation, which we'll sort out in a minute. So we've established that then we have got 15 degrees within that water tank all of the time. So we've done our due diligence in the terms of what the temperature is of the incoming supply on a regular basis. On the majority of the time, that's what it would be, as opposed to poorly installed water main that was not buried deep enough, and so therefore that water temperature is going to fluctuate all the time, and therefore your outlet water temperature is going to change as well if you've only got a DT35 temperature rise throughout the boiler, and that will stop cycling and all sorts of things like that. And then the other side of the boiler would literally come straight out of this side, and that would go to your cold taps. And you could, if you wanted to, you could put a double regulating valve on that to make sure that you've got balanced pressures coming out of your taps downstream, which again is something that I would recommend to be done. But this opens up this whole thing, and it balances your hot water system so you get it correct. This is the point that I'm trying to make, and it's something that we all get wrong, or seem to all get wrong, and don't understand that domestic hot water system balancing or design balancing. This is a typical combination boiler. This is an Intergas technical chart for their HRE, compact HRE boiler, which I have at home. And I have the 2824, which is in this section here. So that means you've got 28 kilowatts there for hot water and 24 for heating, and the same as we run through, right the way through here. You can see, and I'm going to make an argument as to why we wouldn't really want to install any more than a 24 kilowatt. We wouldn't want any more than 24 kilowatts going down 15 millimeter pipe. Now, again, this is my opinion. It's got nothing to do with what CIBSE states or anything like that, but we're all allowed to have that, and we're all allowed to make our own judgments. This is just mine, and you can take that on board or not. But if we look at our domestic hot water flow rates that we get through these different boilers, so you can see at 40 degrees, we've got 10 litres per minute coming out of the smallest boiler that they do. Yep. We've then got 12.5 litres, or for a 28-24 boiler, which is what I've got. Or we've got 15, etc., etc., etc. But you can also see that it changes at 60 degrees, and we'll get the IMI High Tools app out in a second, and we'll check some of these figures, and we'll see if we can get them just about right. But again, that's a DT rise of 25 degrees coming at your outlet, and that's a DT rise of 35 degrees. So you can see you'd automatically expect the flow rates to go down because you need more energy to try and heat it up. So it would slow down that thing. So instead of 15 litres per minute that you would come out of there, you've got 10.5 litres per minute. So if we get the IMI calculator out now, and let's have a little look, and let's play around with some figures, and let's see what we can get. So let's move this over here, because we're going to concentrate on this boiler here. So first thing we've got to do, if you remember, we said we need to set our flow temperature. So if we say we're going to go 45 degrees, right, which is what I'm talking about, a 10 degree water temperature coming in off a water main, 35 DT, as we've got here, a 35 DT rise, that'll give you 45 degrees coming out of your taps. Now, be very careful, because 45 degrees coming out of your taps, if you're elderly, that can scald you, could scald children or that kind of thing. So I'd be careful. This is why RAS state 38 degrees coming out of a tap. But a lot of people will like to run baths and all sorts of things through combination boilers. So they want it hotter, and then they'll blend it down to suit their own personal taste. So that's just a little caveat, just to state that, to say, and I'm not, this is not a regulatory video at all. This is just purely my opinion. So we come in here, we set our temperature, and we set our temperature at 45 degrees. And remember, we said that specific heat capacity changes as we do that. So we can then go to calculator, again go on to power delta T, and we can look at these changes of what we've got. So if we've got a 35 degree delta T change, we'll change that to 35 degrees. 35 degrees. And if we say we've got 28 kilowatts coming in for the hot water on a 28-24, I think because it's 45, we're going to end up around 11 litres per minute, something like that. But the first thing we need to do, let's just double check that our units are correct, and we are looking at litres per minute flow. So we're on litres per second at the moment. So let's put it on litres per minute. Okay, so that'll give us the right result. So 35 delta T. Let's change that now to 28 kilowatt. 28, yeah, there we go. Look, so we've got 11.5 litres per minute. So that kind of, we know that works out about right, because we've raised the outlet temperature to 45 degrees there, just a bit. So that gives us that side there, 11.5 litres per minute. Now, we know that's going to be correct then, so you can set your boiler up for a maximum kilowatt output of your boiler, because we know that we've settled our parameters, we've settled our flow rate, we've settled our delta T, and we've settled our incoming temperature, water temperature. That is how you would set a combination boiler up, and you can set it up to whatever it is that you'd want to do. But again, let's have a look, and this is why I said you shouldn't be trying to get more than around 24 kilowatts down 15 millimeter pipework. And let's all agree that most combination boilers in the UK, not sure about overseas, or they certainly are in Canada, but they will have a 15 millimeter or half-inch inlet and outlet to the actual boilers themselves. So let's have a look at what pipework it's saying for that and make a decision. So you can see at 15 millimeters, to put 28 kilowatts down there, we're under our 1.5, so we're still not going to get any system noise. We are quite high on our resistance now, but again, we're not talking about heating at the moment, so we're not trying to maximise circulation pumps. This is a booster pump scenario. But it's suggesting that we want at least 18 mil to get our 1 metre per second. That's quite a lot. Let's go back to the smaller boiler and let's do that at 24. And you can see we're just getting we just get around 10 litres per minute there. 10 litres per minute. What's that going to do to our pipe sizing? Well, that's closer to our 15mm 1 metre per second Goldilocks zone, isn't it? And this is why I say that I don't think you need to be putting too many kilowatts down 15mm pipe on hot water heat up, because of the 3 points I made, which is system erosion, system corrosion, and component failure. 3 really important considerations when you're doing a design, in my opinion. But let's have a look if you start to go higher, and people want this high water flow rates. They want to have what I would class as ridiculous amounts of water going through. So let's have a look at the big one over here. Let's have a look at the 36. So let's put 36 kilowatts in to try and get 18. So at 35 there, to try and get 13 litres per minute out of the unit, out of the outlet, sorry. So we're back onto this now, and we'll go into 36 kilowatts of input. Now that's because of our delta T has changed, because we said 45. But you can see now, yeah, let's get 15 litres, 15 litres. Yeah, it's spot on actually, that's correct. Because we are going for our 40 degree. So yeah, we're about right on there. I hope this video really helps you, and I hope you can understand why it's so important to consider everything when you're installing a combi boiler, and not just be a white box fitter, stick it on the wall, plug it in and walk away. That's not being an engineer, that is being a white box fitter. Setting it up like this, you guarantee that you're getting maximum efficiency out of your hot water side, and you'll get your boiler's in condensing mode because you're keeping it under that 54 degree dew point, and you're not ever going to get any complaints of difference in flow rates or anything along those lines at all. So it's a good way of setting up, and what do we say? Be a pro if you can. Guys, thank you for subscribing to this. Thank you for watching these tutorial videos. I quite enjoy doing them actually. It's quite a bit of fun. So I will see you on the next one. Many thanks. Bye-bye.